All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to be doing a study stream. But before that, I need to check some things because I am testing out this thing where you can split the audio in how do I say this? You can make it so certain audio tracks don't make it through in the VOD, but they'll still make it through in the live stream. So people who are watching the live stream will hear it. One good example is music. Um, so you can make it so you can let music be heard on the stream live, but in the stream VOD, that music is not going to show up. So I wanted to test that out because I've been having some issues relating to copyright stuff. The music that I'm currently playing, I've noticed my VODs getting muted with their music as well. And when I upload it to YouTube, it still gets flagged by the Content ID system, but fortunately it is allowed by the copyright holders on YouTube. So there isn't too much of an issue. Besides, those videos aren't really monetized anyways, so like there's nothing to lose and nothing to gain either from that. But I did run into an issue yesterday, which is why I feel like I should do this now, this splitting thing now, where so I had a funny moment happen on stream yesterday, just some my immature childish humor. It caused me to laugh at something, and so I took out that segment and I edited the thing, and I tried to upload it to TikTok, but as soon as I published the video, the entire thing got muted. And I don't fully understand how that system is working, because the music that was there, it is available on TikTok, but from what I understand, only a certain segment is available. About, I think, 1 minute worth of that music is available, and I don't know on what basis they're flagging the video, but it could be that the segment that is not part of that 1 minute is what was included in my video, and so the entire thing just ended up getting muted. Or there might be some other reason, I don't know. Either way, I figured it's better to split the audio from now on. Okay, so now that I've been talking for about 3 minutes, I need to test two things. First of all, I need to test whether the music is coming through on stream. So I'm gonna unmute my own VOD. All right, right. So the music is coming through on stream. Great. Next thing I need to do is check my VOD. Give me a second. I need to check the VOD and see if the music is showing up there. So in my case, the setup that I had to do wasn't nearly as complex as other people have to do. One tutorial that I'd watched, it's hold on. So it uses, it's not just that tutorial. Actually, other people have mentioned this as well. In fact, I think the first person that I'd heard this from, I don't remember if she was the first one that I heard it from, but I think the first person I'd heard it from was Little Witch Oz. You guys should go check out Oz. Oz is cool people. But yeah, I'd heard from. I think she's the first person that I'd heard it from. I don't remember exactly. Either way, there's this in OBS. There's a source called application audio capture, and you can use that to capture like individual apps audio. I was about to say capture individual apps audio sources, but basically you can use it to capture the audio from individual apps, and doing it in that way allows you to easily split up the audio, so you can decide which audio makes it into the VOD and which audio doesn't make it into the VOD. Fortunately, in my case, I don't really have a whole lot of stuff that's got audio coming in. It's the audio is mainly my vocals, which is coming from the mic, and then the music, which is coming from a tab in the browser. So the music, the audio, or well, the audio for the music is coming from the browser. So it's basically just these two sources. So for me, all I had to do was just go and uncheck track two, because I believe the VOD's audio is it's taken from track two, which that okay. So that reminds me, I need to do research on this. I also didn't know that they have like two separate tracks, one for live and one for the VOD. I need to do research on this as well, because yeah, I didn't know that was a thing until I enabled this option in settings. Let me just open that up real quick. I also just remembered I was supposed to be checking my VOD to see if music is there. Okay, so in settings under, what is it? Output, I think. Yeah, under output, if you go under the streaming section where well, there's a bunch of options there. If you enable, if you check enable custom encoder settings, then you'll see an option pop up there saying Twitch VOD track, and it says there that it uses track two. So my understanding is that it sets up a separate track, and this is why I wanna learn about how tracks work, because I didn't fully understand how tracks work in OBS and what exactly they do. So I need to do some research on that. But my guess here is that track one is what's going to the. I could be completely wrong about that. So far, this is just my guess. I need to do more research to verify whether that is the case. But my guess is that track one is for the live stream, and then track two is for the VOD. I need to confirm whether that is the case. I also need to learn how tracks work in OBS, and yeah, that's gonna be a later thing. For now, I need to open up my VOD and see what the audio sounds like. So fortunately, the live audio is not affected. Hold on. So I've opened up my thing here. Okay, okay, right. Okay, back up. Let's mute that other thing. Holy shit, dude. It works. Okay, great. Awesome. It's working. Something else that I noticed is that unless I'm talking like really close to the mic, I'm not being as loud as I could possibly be. So I'm considering increasing the gain. I think I already have like two gain filters on the mic audio track. Let me just take a look. Filters. No, I have only one gain filter. I thought I'd put two gain filters. Where did I put the second gain filter? Okay, whatever. I don't know. Under gain, the gain is already set to max, so I would just need to add one more gain filter and just crank up the gain by a tiny bit, and then we should be good. I mean, it's not like it's that bad right now, but like unless I'm super close to the mic, like right now, sometimes my audio might come in a little low, and as it is, I don't really talk very loud, so I kind of need the gain. That's kind of why I've set up the gain thing, because I don't really talk very loud. I don't like talking loud either. But yeah, dude. Okay, so fortunately, in my case, setting up the split audio thing is much simpler than it would be for somebody else who was. I mean, at some point later, if I decide to stream some game or something, I might need to worry about the audio at that point, because well, then I'm gonna have to set up an extra audio source, for an extra audio capture application, audio capture for that game. And then in the mixer, is it the mixer or the advanced properties? I think it's advanced audio properties. Under advanced audio properties, you get the option to select which audio source gets goes into which track. By default, everything is checked, I believe. So all the audio sources go to all the tracks, and I don't think all the tracks are being used. I think you get 5 or 6 tracks, and out of that, I believe two are being used. One is for the live thing, and the other is for the VOD thing. I don't know if the other three are being used. The other three, four, whatever. Let me just open this up. Yeah, so there's 5 in total. So I don't know. I don't know if the other three are being used for anything. I think back in the day when Twitch had this was, I think, a year or two back, maybe 2 years back. Twitch had released this thing. I don't know if they're still doing it, but Twitch, I think it was called Twitch Soundtrack. Hold on, let me just look this up so I can give you proper information. Twitch Soundtrack. I think it was called Soundtrack. Yeah, yeah, it was called Twitch Soundtrack. I don't know if it's still a thing. If it's still a thing, then great. Oh wait, Uh, I'm seeing a post from July 2023, so a year ago. There was a thing that said that Twitch Soundtrack is being shut down. Okay, so let me open this blog post, which was introducing Twitch Soundtrack, and let me see if there's anything here that's mentioning that it has been shut down. Because okay, I joined the thing very early on, at least like very early on, once it was available to the general public. I joined Soundtrack. I downloaded it. I even they had like a separate plugin. They also had a separate app, I believe. Yeah, yeah. I think there was a separate app. So you would play the music in that app, and then there was this plugin in OBS that would capture the music in such a way that, or that would capture the audio in such a way that um, it would not show up in the VOD. You could, I believe you could set it up in multiple ways. I don't remember like all the details surrounding it, but I do remember that initially it was rough. It wasn't perfect. And one of my VODs, when I changed some of the settings midstream relating to that plugin, it desynced the audio badly in my, and not just desynced, it created this weird sort of not even echo, it was more of like a looping kind of effect. There was like a weird audio glitch that happened in one of my VODs just because I changed one of the settings. The program wasn't perfect, the plugin wasn't perfect. It was still in its early stages, so like that's understandable, but I didn't really use the program much after that. Anyways, my point is that what why was I talking about Soundtrack? Oh yeah, I think I was saying it because I think Soundtrack was also using tracks to kind of like separate the audio and stuff. Um, but yeah, yeah. In the future, if I do, because like I don't really stream games. Most of the stuff that I stream is, well, this I do study streams and building streams and stuff, and I usually don't have situations where I need to play audio unless I'm doing actual like audio programming related stuff. Then yeah, sure, maybe I might need to play audio. There might be other situations where I don't know. Let's say if I set up a soundboard kind of thing. At some point, I kind of want to set up a soundboard as well. I'm still not entirely sure how I want to go about doing that because there was this thing I had in mind for it was a project idea for a stream deck, a physical stream deck kind of thing, but for like specific purposes. Because like the stream deck, the stream deck thing itself, it's very general purpose, which is why it's been so widely adopted and why it's so widely preferred. because like they've done a bunch of the heavy lifting for you. You don't need to worry about how their program is interacting with various other programs that you're trying to communicate with. They give you a lot of the support like out of the box, right? At least that's my understanding of it from what I've seen and what I've heard from other friends of mine who have used what do you call it? I lost my train of thought. Who have used and are continuing to use Stream Deck. So it's a very general purpose thing, right? What I wanted to do is I wanted to make my own my own physical Stream Deck. Making the Stream Deck itself is not a very big deal because I would just need to create like a keyboard matrix kind of thing, and like hook that up to a microcontroller, and then I would be getting inputs from that. The main challenging part of that is going to be the software side, because I need to, like, I mean, I'm not trying to make something general purpose. I'm making it for specific purposes, and based on what I want to do, I can write the code, you know, at that time for it. I have that. Fortunately, I have that luxury, and I have that kind of knowledge that I can do it when I need to do it. So I don't need to make something general purpose, but it's still that it's still going to be a tiny bit challenging. For the time being, what I wanted to do is I wanted to set up a soundboard program, and of course set up the soundboard software as well. No, the soundboard hardware is what I was trying to say. I wanted to set up this soundboard hardware as well. I'm not entirely sure how I want to go about doing this. Also, like I'm not too sure like to what extent I want to do the soundboard thing, because like there's multiple ways that I can go about it. I could have like a physical device that I use as a soundboard. I could also have I could set up something similar to my virtual Stream Deck application, which, speaking of which, I forgot to turn that on. Give me a second. Let me open up the virtual Stream Deck. Where is it? Here. Yeah, so I could set up something similar to my virtual Stream Deck. In fact, I could use the virtual Stream Deck itself, in which case I would just need to create an application that that receives input from the virtual Stream Deck, and it plays sounds accordingly. That would be like a lot simpler. It's just that I would then need access to that panel. You know, I would have to have that panel in front of me in order to play that sound. And depending on how quickly I need the sound to be played or how quickly my response time should be, you know, like let's say there's some kind of bit going on, or in that moment, in those few seconds, if I play the sound, then it's going to be funny. Then you know, I would have to do it relatively quicker. But like if there isn't really too much of a rush, I guess I should call it. Give me a second. Streamlit run app.py. Okay. Yeah, if there isn't like too much of a rush, if timing isn't like that big of a deal, then yeah, I could set up the entire thing like in a software with a software based approach, which reminds me, I don't think I ever open sourced my virtual Stream Deck. I should do that at some point. I think the thing is done. I don't remember if it's done. I think I wanted to add something to it for storing the. You know what? Let me open the thing up here. All right, so let's copy this, bring it here, and okay. Give me a second while this is loading. I need to BRB and check something. Because this thing takes a couple of seconds to load. So while it's doing its loading thing, okay. All right. Okay. So this is the virtual stream deck. Um, I need to, I was supposed to check the edit thing, right? So under edit, what I wanted to do is I wanted to, actually, let me show you why I'm trying to do that. So let me open the debug thing. In debug over here, each of the buttons has an event name associated with it, but it also has an event value type and an event value. These are extra bits of information that I chose to attach to it because it works for the specific purpose that I was trying to use it for. But I haven't added I haven't added UI in the edit screen in edit mode to be able to, enter that information, to be able to choose the value type and enter a value and stuff like that. So I need to do that. And I think then I can open source it. Because like for the most part, this entire thing is pretty stable, at least from what I've seen. Like I haven't had to dig into the code for a long time. The last time I had to dig into the code was when I had added a new event to my vtuber app, and that event also needed to be added to the enum in this app, in the virtual stream deck app. That was the only time I had that issue because I'd forgotten that this is how I had set the thing up. But okay, while we are here, let's just do that. Okay, cool. So, we were gonna do stats related things. I was gonna do research on some stats basics. What I had in mind for today is there's a list of topics that I wanted to go over before I move forward with what do you call it, with machine learning, before I move forward with even linear regression, because I read up on linear regression, but I haven't actually used linear regression so far. I haven't done any of it practically. I've only read up on the theory, if that makes sense. So I need to do it practically as well, just so I get a better understanding and, well, just so I actually start using it, because what's the point of learning it if I'm not using it, right? Or, well, rather I should say, what's the point of just learning it and not getting any practical knowledge of it? Like, at least to me, just the theoretical knowledge, at least in this case, it's not really enough. I need to use the thing. I need to practice with the thing. And I'm pretty sure I'm going to have use cases for it in the future as well. Linear regression oh, I accidentally hit my filter. Yeah, linear regression and a bunch of other, machine learning related methods, I should say, data science related methods. I want to learn them and I want to practice them because I need to apply them in data science contexts, but also in machine learning contexts. Or rather, I should say, I want to apply them in machine learning context, but there's also another use case that I have, which is not really related to machine learning, which is a data science context. I need to apply it in that because there's a bunch of IRL use cases that I have for it, which I want to actually use it for. What else? Yeah, I think that's it. Let me just hydrate real quick, and then we can start reading. So actually, I'm gonna read out all the topics as well that I need to cover before I'm able to um, topics that I want to cover before I'm able to move on to, other data science related stuff, because it seems like this is very basic statistics, and I don't know statistics. So, I mean, I know select few topics of it, but I never really studied statistics. So, whenever I run into certain topics that I don't know about, then I take my time and do research and learn about them, and then I move forward. But at the same time, I kind of also need to be careful not to get too bogged down with trying to understand the math behind it. I kind of want to get a high level understanding. I don't want to learn how to implement the methods. I want to learn how to use the methods, because I know that there's going to be Python modules that allow me to use those methods. So I want to get an understanding of how the methods work, but not necessarily how to implement those methods from scratch. I can get an understanding if I need to, but the thing is, I don't need to. Like that's the that's the luxury that we have with Python and various data science related libraries. It's that we don't absolutely need to learn how to implement all of these things from scratch. If I ever need to implement it from scratch, then yeah, sure, I can take the time to learn the math behind the specific things that I need to implement from scratch. Like, for example, if I was going to be writing something for running on embedded hardware. The funny thing is, there's a decent chance that if I did decide to do this on embedded hardware, there's a decent chance that somebody has already written a library for it. And so I won't need to do I won't need to do a whole lot of work for that either. But yeah, okay. Give me a second. Let me hydrate, and then I'm gonna start reading this. Actually, I also have to read out the topics. Oh, you know what? In about 3.5 minutes, there's gonna be an ad playing. So I think what I can do is, yeah, you know what? I'll hit the run ad button now, so it doesn't interrupt the stream later on, and I'll see you guys in 30 seconds. All right, welcome back. Give me a second. Okay, so in my list of topics that I have, some of them I've already learned in the past, but I just need kind of a refresher on them, just to get that knowledge back again, because I haven't used the methods in a while. And basically, what happens when you don't practice stuff, you kind of just forget it, right? Actually, you know what? What would be a good? I feel like something that would be a good excuse for me to use Rust is I could look up a stats library. Actually, there was another thing. There was a plotting library that I'd seen on Rust. I think it's called Plotter or Plots. I don't remember. But yeah, there was a visualization library that I'd found. Of course, there's also Win32 stuff that I wanted to do with Rust, which I did to a certain extent. But then I kind of shied away from it when I started to notice that certain things were using stuff like raw pointers, and I hadn't read up on raw pointers, so I didn't want to mess around with that, and unless I really needed to. But I do want to carry on practicing Rust, so like I'm gonna find whatever excuses I can to use Rust. Um, but yeah, I need to remember because, dude, I okay, so I already have C Sharp and Python as my quote unquote daily drivers. I want to add Rust as my daily driver as well. Because I mean, I've been doing C Sharp and Python for a decade, so like I don't really need practice in them. I'm using them to a certain extent, you know. Every now and then I'm using them to a certain extent, and with the amount of experience that I have in both the languages, there's I won't be forgetting the syntaxes or various features of them anytime soon. Of course, there are certain situations where, you know, there are certain language specific things that I forget and I run into issues, but whenever I do run into those issues, a quick a quick Google search, it answers the question, it solves the problems. So I want to get to that point with Rust as well, just so I have the foundation solidified, and I don't need to worry about forgetting a bunch of Rust related features. Because like once I get into data science stuff and ML stuff, I'm gonna be able to do um, data science and ML stuff in both Python and Rust, because there are libraries that provide you with the abilities to do those things in both of the languages. Like each language has a set of libraries that allow you to do that. So if I needed an excuse to practice Rust, then well, there's a pretty good excuse for me. There's also another thing that I wanted to look into, which, dude, I really want to explore Win32 stuff, because it's pretty interesting to me. And something that I want to explore is the input side, like sending input. I want to Okay, so there's a couple of things I want to explore in Win32, because Win32 is massive, right? You shouldn't try to learn the entire thing. Pick specific topics that you are interested in and start exploring from there, start learning from there. So, the specific topic that I'm currently interested in is sending input into other applications, sending keyboard and mouse input, and whatever other type of input um, it's going to accept, right? That brings us to Windows. Windows and messaging and threads and processes. Like these are the topics that it eventually leads to. So I need to do research on those as well. And that's a good starting point for me. Learning about all of this. Because, dude, the great thing is, like, Microsoft has the documentation on all of this. I can show you guys, just as an example. Like, I was talking about Windows and messaging. They explain to you how messaging works in terms of sending input. Because, like, their entire windowing system works on message queues, and you send messages, the messages get queued up, and then they get like consumed one by one. um, Give me a second. So Win32, Windows and messaging. So this is one example. Let me also show you input. So whatever, also I'm aware we are still on the BRB screen. So input, or Win32, let's say keyboard input, or let's say mouse input. Keyboard and mouse input, apps, okay, input dev. All right, great. So I'm going to open this up now. Um, right. So here, did I open up the right thing? I think I opened up the right thing. Yeah. So here you have like this one topic, Windows and messages. Actually, if I follow the breadcrumb trail back, I can probably show you other stuff. So under desktop technologies, I believe they have a couple of these categories, and you can pick any category and then like go deeper into that. So in my case, it was, what was it? Desktop app user interface. So let's take a look at that. Where does this come in? Where does keyboard input come in? So we have user interface, user interaction, legacy features, and keyboard and mouse input. So if we go under desktop user interface, we'll probably see user. What was it called? I forgot. Give me a second. User interaction, and then legacy features. I think it was this user interaction features. Right, here it is. And then there was a thing called legacy features, legacy user interaction features. So you see what I mean? Like there's documentation available for all of this stuff that explains. And so far we are just like looking through topics. It's like one topic, and then that branches out into subtopics. And then each of those subtopics branch out into their own subtopics. So here we are taking a look at, let's say, keyboard and mouse input. And here also we have a bunch of stuff here. Let's take a look at mouse input. And under this, you have these topics where it'll explain how mouse input works, and then how you can use mouse input. And then I think this is for the API, mouse input reference. Let me just open this up to show you. Yeah, there you go. There's a bunch of information here. And it's a similar thing with Windows and messaging. Just to give you an example, let me show you message queues. Messages and message queues. So this gives you an entire explanation of how messages and message queues work. You can also take a look at the same thing for processes, the same thing for windows themselves, how different windows work. And it's great because it gives you insight into how a lot of these windowing systems work. So, I mean, I found it interesting. So the great thing for me is that I can read all of this stuff, and this is mainly talking about using the C++ API, but I can get like a direct, um, should I say, translation? I have like a direct, one-to-one version of that in Rust. So I can use that thanks to the Win32 crate, or the Windows crate. Thanks to the Windows crate, I have like, I think it's an almost one to one. I don't know if it's like exactly one to one, but like it's very close. So like you can find specific functions that you need, and then you can find similar functions in Rust as well. I think the whole idea is to make it as seamless as possible. So like I think they even try to make the names as similar. I mean, not even as similar, like really, really close, really similar, almost the same, just so it's much more easier for you to find the function names. Uh, I think they must have tried to, do that. But yeah, Win32 and data science stuff. So far, these are two things that I have in mind to practice Rust things. But like, dude, to be honest, the Win32 thing alone is going to take up my a bunch of my time in Rust. So I don't even need to add the, what do you call it? I don't even need to add the data science thing. The thing is, a lot of the Win32 stuff, it revolves around unsafe code. So there's a bunch of research that I need to do for that, um, which I'm fine with doing. It's just that it's going to take some time, right? There's a bunch of research I need to do surrounding unsafe code because I believe raw pointers work in a very different way compared to, well, pointers in Rust. And see, I think I'm getting close to forgetting how the whole pointer thing and the borrowing thing and all worked in Rust. And this is kind of why I need to keep up my practice of Rust, because otherwise I start to forget it. Because like Rust has certain very specific features that are like specific to Rust that I have not seen in other languages. And so I don't just like remember it automatically. They're like specific to Rust. And so I need to keep practicing them at least for a while in order to just have that foundation solidified. Okay, dude, enough with this. Let's go back to this. So I was about to read out the list of things that I have to do, the list of topics that I have in mind. For whatever reason, whatever silly reason, I thought that I would be able to complete this list in one stream. Because like I wasn't planning, it's not like I was planning on reading all of these Wikipedia pages that come up for each of these topics. I was mainly going to read like the first few paragraphs of this to get an idea of what exactly it's doing. And then I was going to try and use something like SciPy, for example, to do to basically do whatever those calculations are. Um, that was the plan. So okay, here's my list of topics, stats related topics that I wanted to look into. I'm gonna start with like the basics, but then like some of these are like I've already learned them in the past, but I need to just refresh my knowledge because due to not using them for a while, I kind of just forgot what they mean. Speaking of mean is something that surprisingly I do remember. Mostly because I know that mean basically means average. It's another way of saying average. Then there's median, which I believe median gives you the center value. Like for any given data set that you have, it's going to give you the center value that it can find, the centermost value that it can find. I don't remember what mode is, but that was a simple concept as well. Mode is the value that appears most often in a set of data values. See, that's useful. It's useful to find out the mode. Okay. All right. Okay. I'm going to read out my list that I have. So I had median, mode, central tendency, p value, r squared. So p value and r squared, they came up in discussion yesterday when I was learning linear regression. Right, so I wanted to read up on both of those as well. Fortunately, this person, I think their name is Abhigyan. Where is it? Here. So, fortunately, this person also has some stuff written on p-value and r squared. So we can look up their thing. And in general, I'm also just going to look up those topics on Wikipedia. I have the pages loaded up. When I looked up r squared, something else came up, which is this coefficient of determination. So I think it's called r squared. Coefficient of determination is apparently, it says here it's denoted r squared and pronounced r squared. Is a proportion of the variation in the dependent variable that is predictable from the independent variable. Oh, dude, this is gonna be useful. Okay, hold on. Give me a second. Actually, let me hydrate again. Okay, so my list of values is median, mode, central tendency, p-value, r squared, standard deviation, normal distribution, kurtosis, skewness, and correlation. Before getting into that, there was a word that came up, which is coefficient. I find myself having to look up the meaning of this word like really often, mostly because I don't use it nearly as much. And if I do use it, I don't call it coefficient, or it doesn't get called coefficient. So I find myself forgetting the meaning of this word. Okay, so in mathematics, a coefficient is a multiplicative factor involved in some term of a polynomial, a series, or an expression. It may be a number, dimensionless, in which case it is known as a numerical factor. It says multiplicative factor, so it's just a multiplier. I mean, it depends on what the context is, like what depends on what situation we're talking about. But like, let's say we are talking about it in an expression, would it just be a multiplier? It may also be a constant with units of measurement, in which it is known as a constant multiplier. Okay. In general, coefficients may be any expression, including variables such as a, b, and c. When the combination of variables and constants is not necessarily involved in a product, it may be called a parameter. Wait, back up. When the also, I think the music must have stopped. And you know what? Since we are not um since we are not since we are splitting the audio, I feel like I can test out some other music. By the way, shout out to the Birthday Massacre. Pretty awesome band, pretty awesome music. Go check them out. They've got music going back to like I think even like the late 90s. I don't know. Either way, like all of their music is great. Go check them out. Um I usually don't listen to the music that I'm playing on stream. It's just there as background sound, mostly for the stream, not for me. Um I remember this name though, Scandroid. We could try playing this person's music. There was a song that I'd heard a while back. Hold up. No, there was a song that I'd heard. I think it was so. There's a band called Machine Supremacy, and they had done. Oh yes, Empire of Steel. So Machine Supremacy had done. They had done a cover of a song called Empire of Steel. The original song was apparently made by Scandroid and another person. Let me just look that up so I'm not giving wrong information. But that was like I looked at I'd heard the cover first and then I heard the original. Both are great in their own right. Um but like I because it was one of those things where you ever have this thing where you hear the cover of a song first, which is basically somebody else's rendition of the original. You hear that first and then you hear the original and you're like, dude, I kind of like I kind of like the cover a lot more. It's not that the original is bad. The original is good in its own right as well. But like, which one do you like more? You probably like the cover more, and it might be because you heard the cover first. I've had many such situations. Again, like the original, it doesn't mean that the original isn't good. The original is also great. Like if you listen to the original, but like these are two very different. They're two very different. They have very different vibes. One was a very I don't know what to call it, rock metal kind of vibe, which was from Machine Supremacy, and the other was very a very synthwave kind of vibe. Let me just look this up. So Scandroid, I remember this name. I think I remember this name because of that. Uh, Empire of Steel. I think this was the one. Yes. So this was a song called Empire of Steel by Essenger and Scandroid. That's where I remember this name from. So you know what we're gonna do? We're gonna listen to this person. Actually, you guys are gonna listen to this person's music, and you know what? Whoever is on the stream is gonna listen to this music. The VOD watchers are probably not gonna be listening to that because split audio. Hell yeah! Give me a second. Let me just confirm that. Is the music coming through? Hold on. The music has just started, so it hasn't like gone into its whole, It's just started, so it hasn't like gone into its whole. Okay. All right. So I just need to confirm that this is not, it's not like overpowering what I'm saying. Because something else that I noticed in yesterday's clip was that unless I'm really close to the mic and I'm making sure I'm talking in such a way that I'm heard through the mic, unless that's the case, there's a chance that the music might start overpowering my sound, which is why earlier I was talking about adding another gain filter. I'm just waiting for this thing to. I'm just waiting for like some kind of beat to drop, or the song to like go into its thing. Because that's how I can determine how what volume I should be setting. I determine it based on whatever the loudest parts of the song are. All right, you know what? This is probably not that bad. I can. I'm looking at the meter as well. Actually, this is great. This is not that bad. Yeah. So we got music running in the background, and yeah, cool. So we're gonna go back to what we were doing. I was looking up coefficient. Let me just Google this so I can move on from this topic. Actually, let me try asking Gemini. I also just realized that my stream is unmuted. Okay, so I'm gonna ask Gemini, um, is a coefficient just a multiplier? The obvious answer is no. It's gonna say that it's not necessarily always the case, but yeah. I want like in simple terms. So it says yes, essentially a coefficient is a multiplier. Um, However, it's important to note that so and so, so and so, so and so. Okay, yeah. So that's the answer I was expecting. So let's read this. So it says, is a coefficient just a multiplier? Yes, essentially a coefficient is a multiplier. It's a numerical factor that is placed before a variable in an algebraic expression. This number indicates. Wait, why does it say before? In an algebraic expression, the multiplier would be okay. Uh, this number indicates how many times the variable is multiplied. All right. In the expression 3x, the coefficient is 3. This means x is multiplied by 3. However, it's important to note that coefficients can be negative. For example, negative 2y. In negative 2y, the coefficient is negative 2. Coefficients can be fractions. Okay, all right. Coefficients can be variables themselves in expressions like so and so, so and so, so and so. Okay. While the core concept is multiplication, understanding these nuances is crucial for deeper algebraic work. Would you like to see some examples or solve a problem involving coefficients? No. Okay, great. So I think we can move on from that. And next, we can look at median. The median of a set of numbers is the value separating the higher half from the lower half of a data sample. The middle value, there you go, of a data sample, a population, or a probability distribution. For a data set, it may be thought of as the middle value. The basic feature of the median is describing data compared to the mean, often simply described as the average. No, wait, back up. The basic feature of the median is describing data compared to the mean in, oh, I said is. Okay. The basic feature of the median in describing data compared to the mean is that it is not skewed by a small population, no, by a small proportion of extremely large or small values, and therefore provides a better representation of the center. Median income, for example, may be a better way to describe the center of the income distribution because increases in the largest incomes alone have no effect on the median. For this reason, the median is of central importance in robust statistics. All right, so that's the information I needed on median. Next, mode. Oh, yeah, we looked into this earlier. In statistics, the mode is the value that appears most. And you know what? Okay, as we are doing this, we can also practice. So, do I need to actually? I don't know if I need to reactivate the environment. So I'm just gonna check that real quick. Um, check, testing. Check. Okay, so for a second there, I was like, am I not coming through all that well on the mic? I'm looking at the levels right now, and it kind of seems like I'm not coming through that well. No, you know what? I think I'm coming through fine. And there's also music coming through, which is okay. Like the whole idea is that it's not overpowering whatever I'm saying. The funny thing is now I'm gonna have to remember that whatever I'm like whenever I'm talking about the audio, I'm gonna have to remember that this audio is not gonna be coming through on stream. Well, no, this audio, this music is not gonna be shown in the VOD. So if anyone is watching the VOD, then me talking about the audio is not really gonna make a whole lot of sense. I'm gonna need to remember this because there's a decent chance that I'm gonna forget it because this is like the first day that I'm doing this. Um, for the past couple of years that I've been streaming, I don't think I've ever done split audio. This is literally the first time I'm doing it. Fortunately, like I mean, good on me. It worked the first time, though. I feel like things were a little easier for me, mostly because all I had to do was remove the entire desktop audio. So like it was much more simpler for me as compared to other people. But like even for other people, it's not going to be that complicated. It's just the setup is a little tedious. But after the initial setup, you're good to go. You can like select which audio sources should go to which track. But yeah, okay. Oh shit, I'm still on BRB. Um, oh yeah. That was a reason why I was on BRB. Give me a second while I see if I need to activate this environment because this terminal thing is going to open and then I need to see if the environment is activated. And there's also this thing, this confusing, super confusing thing, by the way, that happens where it says that the environment is activated even though it doesn't show that the environment is activated. um I really wish they would change that and just show that the environment is activated, because like the way that they show the environment is activated is by um, having the name of the environment in parentheses next to whatever the path is. I'll show you guys what I mean. Okay, so let's open up command prompt. Okay, so the environment is not activated here. I don't remember which situation I was in where the environment had gotten activated like by itself. I think it was like re restarting or reopening VS Code. I don't remember. Okay, so we are gonna activate this environment. So it is what env slash I think scripts slash I think activate. Wait, why does it say this? All right. Oh, let's try this. All right, great. So actually, let me bring this up here so you guys can see what I'm talking about. So this is how it shows that the environment is active. And in this case, the environment names, in this case, the environment name is just env. And yeah, it puts it into parentheses, and that's how you know that, yeah, this is the environment. So now that the environment is activated, with SciPy, we are going to check. I think I first need to create a data set. Well, we have a data set here, right? Wait, does it take lists alone, or does it actually need specifically NumPy or pandas? Well, not pandas, NumPy. Does it specifically need a NumPy array? Let's take a look. Let's see. Also, I think doesn't NumPy also give you a median option? Okay, so let's look this up. SciPy median. Stats.median. Okay, so there's a st.median. For some reason, it's not showing up. Why does SciPy stats describe does not have median? Oh, there's a describe thing. Okay, so does this give us a bunch of information about a data set? Compute several oh, dude, okay. Compute several descriptive statistics of the past array. So what all information does this give us? It returns knobs. Oh, number of observations. What else? Hold on. Min max, mean, variance, observation. No, skewness, kurtosis. Okay, a bunch of them are just given here. Okay, cool. Great. So describe does that for us. So here's what we can do. Oh, also, what does describe take? What are the parameters? It takes in what any array like. Okay, so a list works, doesn't it? And then axis, int or none, optional. Axis along which statistics are calculated. Default is 0. If none, compute over the whole array A. Okay, what is DDoF? Delta degrees of freedom, only for variance. Okay, so I can look into that later. I think I can ignore a bunch of these for now. Maybe axis, I would need to mention none. But other than that, okay, so there's bias as well. If false, then skewness and kurtosis calculations are corrected for statistical bias. Oh, I feel like, hold on. What is statistical bias also a separate topic? Statistical bias. You know what? Bias has actually come up in machine learning quite a bit, like a lot. So I need to look into this. So give me a second while I open this up. Uh, what is it? Stats bias. And then we are going to read up on this. And I'm also going to add it to my list here. Bias. Great. So let's do a quick read of this. We're not going to go too deep into this specific thing, but we can do a quick read of it. So in statistics, the bias is an estimator or bias function. No, the bias of an estimator is the difference between the estimator's expected value and the true value. Isn't that like an error? An estimator or decision rule with zero bias is called unbiased. In statistics, bias is an objective property of an estimator. Bias is a distinct concept of consistency. No, bias is a distinct concept from consistency. Consistent estimators converge in probability to the true value of the parameter, but may be biased or unbiased. See bias versus consistency. All else being equal, an unbiased estimator is preferable to a biased estimator, although in practice, biased estimators with generally small bias are frequently used. When a biased estimator is used, bounds of the bias are calculated. A biased estimator may be used for various reasons because an unbiased estimator does not exist without further assumptions about a population. Because an estimator is difficult to compute, as in unbiased estimation of standard deviation, because this is like a run-on sentence. Okay, because a biased estimator may be unbiased with respect. Oh, they're giving like all the different situations. Oh, okay, all right. Because a biased estimator gives a low value of some loss function compared to the unbiased estimators, or because in some cases, being unbiased is too strong a condition, and the only unbiased estimators are not useful. Okay. Maybe I'll get into this later. For now, because I feel like what I'm seeing, at least from that little thing that we read, what little we have read on this, it kind of seems like the bias is error, but like I think it might be considered error in like a specific scenario, and that's the scenario that I'm looking at it from. Maybe in other situations, it might be used for something else. It might be considered something else. So, yeah. Um, okay. Back to median. We were trying to find out median. It says here NumPy has median, which is fine, but like I'm looking for the thing in stats, in scipy.stats. Since this is the top hit on Google for weighted median, in NumPy, I will add my minimal function to select the weighted median from two arrays without changing their contents and with no assumptions about the order of the values. On the off chance that anyone else comes here looking for a quick recipe for the same exact preconditions. Okay. Um, I cannot speak for SciPy, for the SciPy stats.describe people, but the general answer is that mean, variance, and even kurtosis can be computed in one or two so-and-so passes through the data, while median requires so-and-so. Okay, all right. So can I get the median or not? Because what I'm seeing is, all right, hold up. Let's go back to this thing. So here we have stats, and under stats we have median. Um, Compute the median absolute deviation of the data along the given axis. Okay. Then we have median test. What does median test do? Perform a moods median test. Test that two or more samples come from populations with the same median. Okay, so there's no like straightforward method. All right, it's fine. So import numpy as np, and now we can do median. What does median accept? It accepts an array like something, right? Hopefully it accepts a list. So let's give it 1, 2, let's give it something out of order as well. So let's do 7, 4, 5. So here the center value should be 5, right? But 5, I've set it to be last. So let's print out this. We can also get rid of these two, these 3, these 4. All right, so run that. You see how quickly I was able to just jump into doing the coding in Python. Earlier when I was mentioning that I want to make Rust one of my daily drivers, this is what I was talking about. I want to be so fluent in Rust that I can just jump into it without having to think about, syntax and various features and stuff all that much. Because like I can jump into anything C sharp and anything Rust, no, anything C sharp and anything Python really quick. Because those are my daily drivers, and I've been doing both of those languages for like a good decade. C sharp is actually more than a decade. So like I want to have that kind of experience with Rust as well. I want to be that comfortable with Rust as well. Okay, give it a second while this thing does its thing. And oh, is it done? Okay, we have an error. So let's try to restart the kernel. How do we go about doing that? Um, okay, wait. Let's try this again and let's see if it works. While this is doing its thing, I guess I'll hydrate as well. You guys hydrate as well if you haven't been hydrating, because like, dude, holy shit. I've been talking for a while and like it is doing things to my throat and mouth. All right, so I cannot remember how I had done this previously. I don't know if I need to. Yeah, I guess okay, we'll just wait. Oh, is it done? No, it's still trying to run. Okay, okay. I think we're gonna get some results. Give it a couple more seconds. Actually, we're gonna give it as long as it's gonna take because like once this timer starts, once this thing starts, that usually means that it's running and it's gonna give you the result at some point. How long that's gonna take, can't say anything because like I'm running this. This is like a first run kind of thing. The first run ends up being quite slow, but then it slowly, I don't even know how to explain it. It's kind of like it's one of those things where it's like an old car. You have to like warm it up before running. If you don't warm it up, then like there's chances of the car stalling. It's it's kind of like that. So like you just have to like it sounds like a silly analogy, but like this is what I've noticed. Like you have like the first run thing, and once the first run is done, then everything runs smoother. Or once the first few runs are done, then it slowly starts to run a little bit smoother. Because so far it's just this one thing that's being calculated, and it's not even that big to calculate. Okay, you know what? While this is running, we can move on to some other thing. Oh, I was supposed to look at mode as well. I don't think we can move on to something. Where was mode? I think mode is here. Yeah. So mode tells us how many times a value appears most often in a set of data values. The mode is the value. Oh, wait, no. Okay, yeah, no, that's true. The mode is the value that appears most often um, in a set of data values. Okay. If x is a discrete random variable, the mode is a value x at which the probability mass function takes its maximum value. In other words, it is the value that is most likely to be sampled. Okay, that helps a lot more. Like the statistical mean and median, the mode is a way of expressing in a usually single number important information about a random variable or a population. The numerical value of the mode is the same as that of the mean. No, the numerical value of the mode is the same as that of the mean, and the median is an. My God, hold on, dude. The numerical value of the mode is the same as that of the mean and median in a normal distribution, and it may be very different in highly skewed distributions. Okay, so normal distribution and skewness is also something I'm going to be looking at later. I already have normal distribution opened up here, and then there's skewed distribution. I already have skewness opened up here as well, which I'm guessing it kind of leads to something here. Oh, good. Okay, this is done. Oh, I was wrong. Yeah, I just noticed. Like, if I lay these numbers out like this 1, 2, 4, 5, and 7, 4 is the median, 4 is the middle value. All right, great, awesome. So we have our So we have our data set here, right? A equals this. All right. np.median. Okay, cool. Then we can do what st.describe. So that's going to give us the mode. Actually, we don't have recurring values here. I need to add something more. Actually, what happens if there is nothing that occurs the most? Like what value does it give us then? Let's test that out. So the mean is this. Wait, does it not give the mode? It's not giving the mode. Is there some other way to get the mode? Like that. Okay. All right. Let's print that out. Mode result. Mode 1. Mode 1, count 1. Okay. That's not really telling much. Okay. Let's try increasing the number of times 4 appears. And let's see if it changes our thing. Oh, mode is 4. Okay. Okay, so that's what mode means over here. And in the other case, when it did this, I wonder if it just took like the first value that it got, because like all of the values only appear once, right? Like that's the whole idea with mode, isn't it? Hold on. The mode is the value that appears most often in a set of data values. Yeah. Okay. So technically, one is not wrong, but like by that logic, none of the others are wrong either because they all appear at least once. Um, okay, cool. Wait, what happens if I do this? All right, so then it picks the next number. Okay, let's try adding a bigger number here. Let's see what happens then. All right, so it's still picking the smallest number. All right, cool. Great. What was the next topic on the list? Central tendency. In statistics, a central tendency or measure of central tendency is a central or typical value for a probability distribution. You know what? I should probably read up on the definition of probability distribution just so I have an idea of like, because I'm seeing this term come up multiple times and I just want to have a proper idea of what exactly it means. In probability theory and statistics, a probability distribution is the mathematical function that gives the probabilities of occurrences of possible outcomes for an experiment. In a mathematical description, no, it is a mathematical description of a random phenomenon in terms of its sample space and the probabilities of events. For instance, if X is used to denote the outcome of a coin toss, which is the experiment. Okay, let's read that again. In probability theory and statistics, a probability distribution is the mathematical function that gives the probabilities of occurrences of possible outcomes. A, a probability distribution is the mathematical function that gives the probabilities of occurrences of possible outcomes for an experiment. It is a mathematical description of a random phenomenon in terms of its sample space and the probabilities of events. Okay, For instance, if X is used to denote the outcome of a coin toss, which is the experiment. Oh, the outcome. Okay, the outcome of a coin toss. The coin toss here is the experiment, and X is the outcome. Then the probability distribution of X would take the value 0.5. Oh, because it's 50-50, right? 1 and 2, or so and so, for X equals heads, and 0.5 for X equals tails. Dude, this is kind of interesting. Hold on. Wait, so the probability distribution gives the probabilities of the occurrences of possible outcomes. So there can be any number of outcomes for any given experiment. The probability distribution gives you the probability of those outcomes happening. Okay, all right. So let's see if, how do you even go about like reading, how do you even go about getting a probability distribution with like a simple list? Like, what are you looking for? Okay, so statistical functions. This module contains a large number of probability distributions. Wait, so there's a probably a list of stuff, right? Okay. All right. What about general probability distribution? All right. Okay. Okay. More commonly, probability distributions are used to compare the relative occurrence of many different random values. Probability distributions can be defined in different ways and for discrete or for continuous variables. Distributions with special properties or for especially important applications are given specific names. Okay, introduction. A probability distribution is a mathematical distribution of the probabilities of events, subsets of sample space. Subsets of the sample space. Okay, let's ignore that last part. The sample space, often represented in notation by, I think that's omega, I think. Okay. Represented in notation by omega is the set of all possible outcomes of a random phenomenon being observed. The sample space may be any set, a set of real numbers, a set of descriptive labels, a set of vectors, a set of arbitrary non-numerical values, etc. For example, the sample space of a coin flip could be so-and-so. All right. To define the probability distributions for specific cases of random variables, so the sample space can be seen as a numeric set, it is common to distinguish between discrete and absolutely continuous random variables. In the discrete case, it is sufficient to specify a probability mass function, P, assigning a probability to each possible outcome. Example, when throwing a fair die, each of the 6 digits, 1 to 6, corresponding to the number of dots on the die, has a probability 1 in 6. That makes sense. The probability of an event is then defined to be the sum of the probabilities of all outcomes that satisfy the event. For example, the probability of the event the die rolls an even value is so and so, 1.5, because it has 3 even numbers and 3 odd numbers. Okay. Well, not 1.5, 1 and 2. So it's a 50-50 chance that it rolls an even number. In contrast, when a random variable takes values from a continuum, then by convention, any individual outcome is assigned probability 0. For such continuous random variables, only events that include infinitely many outcomes, such as intervals, have probability greater than 0. Wait, what? For such continuous random variables, only events that include infinitely many outcomes such as intervals, have probability greater than 0. All right, okay. Right, now I need to look into how SciPy allows us to calculate probability distribution. So here's what we're going to do. I'm going to Google it. Man, I'm opening up so many tabs here, and I'm going to close all of these tabs once the stream is over. So I need to make sure I note down all of these. So probability distribution. So there's like a bunch of topics I have over here. The thing is, after the stream is over, I cannot carry on reading this. I have some other research that I have to do because there's this other project that I was supposed to be working on. So, oh shit, I missed the ad timer. Okay, so there's going to be an ad playing in a bit. Oh, well, there's the ad. So, yeah, I guess I'll take a 30-second break. All right, welcome back. I'm still just looking this thing up. So probability distributions. Let's open up that page and see what we have available here. Python, SciPy, add probability distributions. Okay, all right. Okay. So let's transition back and see what this says. This module contains a large number of probability distributions, summary and frequency statistics, correlation functions, and statistical tests. No, correlation functions and statistical tests, masked statistics, kernel density estimation, quasi Monte Carlo functionality, and more. All right. Okay, great. Statistics is a very large area, and there are topics that are out of scope of SciPy and are covered by other packages. Some of the most important ones are these. Okay, great. You know what? Maybe I should look at the maybe I should look at the documentation for stats models as well. All right, probability distributions. Each univariate distribution is an instance of a subclass of RV continuous and RV discrete. Okay. Wait, there's a bunch of different stuff here. Holy shit, there's... Oh god, dude. There's a lot here. Alright, what about summary statistics? So that's where describe comes. Okay. Then we have frequency statistics. Oh, you know what? Okay, this is sort of like a... Wait, no. So this is under probability distributions. I'm looking at probability specifically. The other stuff, so this is all like... This is basically the stats thing. The stats... Yeah, there it is. We are... SciPy... somehow I didn't notice this earlier. We're looking at scipy.stats. Yeah, so that's going to be like a massive thing, right? I'm looking at probability distributions specifically. And then under that, we have these things. that I'm also looking at. So we have continuous distributions, multivariate distributions, and discrete distributions. I need to figure out, dude. There's no way I'm gonna read up on all of these. A lot of these seem to be saying random variable. I need to look into what that's all about. Okay. Yeah, a lot of these seem to be talking about random variables. So I need to look into what each of these things does and why we have these different ways of generating random variables. That's kind of interesting. So yeah, I'm going to look into statistical, well, functions, and we can carry on to the next thing in the list, which was central tendency. Actually, that's what we were reading, wasn't it? And that's when I interrupted myself. Okay, so in statistics, a central tendency is a central or typical value for a probability distribution. Colloquially, measures of central tendency are often called averages. The term central tendency dates from the late 1920s. The most common measures of central tendency are the arithmetic mean, the median, and the mode. A middle tendency can be calculated for, wait, hold on, back up. Central tendency. Central tendency is a central or typical value for a probability distribution. But a probability distribution is the probability of certain outcomes occurring in an experiment. So a central tendency is a central or typical value for a probability distribution. Let me read that again. In statistics, a central tendency is a central or typical value for a probability distribution. So this tells us what the central value would be in a probability distribution, because the probability distribution is going to give you the probabilities of various outcomes. So the central tendency is going to give you the central, which is basically the mode, isn't it? No, which is basically the median. It gives you the median of the outcomes. It gives you the median of the probabilities of the outcomes, isn't it? Hold on. Let me try asking Gemini. In statistics, is central tendency, did I spell that wrong? Tendency has an E after D. Okay. This is central tendency the same as mean, median, and mode? All right, let's see what it says. Central tendency versus mean, median, and mode. Central tendency. No, central tendency is not the same as mean, median, and mode. Central tendency is a general term that refers to the idea of finding a single value that represents a data set. It's a concept, while mean, median, and mode are specific methods or measures used to determine the central tendency of a data set. To summarize, central tendency is the concept of finding a representative value. Mean, median, and mode are specific calculations to find that representative value. So how would we use this in a sentence? Would we say that we are finding the central tendency? Dispersion. I think I've looked into dispersion. Is dispersion the same as spread? Hold on. Okay, so let's open that up as well for later on. Okay, think of it like this. Central tendency is the goal, and mean, median, and mode are different paths to reach that goal. The best path depends on the specific characteristics of your data. Okay, so would it be right to say that when we are calculating the mean, median, or mode of a data set, we are calculating the central tendency, or we are calculating the measure of central tendency? I'm, I'm still not getting it. Okay, so the most common measures of central tendency are the arithmetic mean, the median, and the mode. A middle tendency can be calculated for either a finite set of values or for a theoretical distribution, such as the normal distribution. Occasionally, authors use central tendency to denote the tendency of quantitative data to cluster around some central value. The central tendency of a distribution is typically contrasted with its dispersion or variability. Dispersion and central tendency are the often characterized wow are the often wow dude, sometimes I'm stumbling on my words, sometimes I'm fucking like choking. Dispersion and central tendency are the often characterized properties of distributions. Analysis may judge whether data has a strong or weak central tendency based on its dispersion. Measures. The following may be applied to one-dimensional data. Depending on the circumstances, it may be appropriate to transform the data before calculating a central tendency. Examples are squaring the values or taking logarithms. Whether a transformation is appropriate and what it should be depend heavily on the data being analyzed. All right, so we have mean, we have median, mode, and then we have a bunch of different kinds of means, which I'm not going to get into right now. Uh, and there's a couple of different medians as well. So I still don't get why do we have this seems like a very generalized term. If we are able to use a bunch of different methods to find it, it seems like a very generalized term. Let me just look this up again. What is central tendency? Let's look this up on Stack. No, let's look this up on Reddit. Why do we need different measures of central tendency? Okay, so there's a post here saying everything you need to know about central tendency. What is central tendency again? Let me just um central tendency is a general term. Oh, it also, yeah, it did say it's a general term that refers to the idea of finding a single value to represent a data set. But that one value that you are trying to find oh, the idea of finding the central tendency is the idea of, like, you're basically trying to find one value that represents this data set, but then you get to choose what method you use to determine what the central tendency is. So the central tendency can then be based on the mean, median, mode, or whatever other 10, 20 methods that are listed. It can be any of those methods. Colloquially, measures of central tendency are often called averages. So then it could be mean. The most common measures of central tendency. So, okay, it's a general, right? So this kind of helps. Central tendency is a general term that refers to the idea of finding a single value to represent a data set. Because mean, median, and mode are all single values. Well, mode, I mean, mode mode is also a single value. Though, like, I mean, in the function that we ran here, it gave us an extra value, but I don't think that's necessarily part of the answer. That's just some extra information that's coming. The main answer of mode is basically which value occurs the most, right? I think so. I hope I'm remembering that right. Yeah, yeah. That's mode. It's which value occurs the most. Okay, cool. Dude, I have no idea if I'm even gonna remember all of this shit later on. Cause like I'm not sure how many situations I'm gonna be using these concepts in. So like all I can hope for is that I remember this, or at the very least later on I'll come back to this and I'll just have to refresh my memory. I'm not gonna have to reread everything or re-study, re-understand everything, learn it from scratch. Basically, I'm not gonna have to do that. Hopefully, but okay. I kind of get the idea of central tendency now. Um, moving on to Oz. Hello, hello. Welcome to the stream. How are you doing, Oz? Statistics is going well. It's actually going really well. I surprisingly managed to stay on topic today, though to be fair, there were a bunch of different topics that I jumped between, so I don't know if I would call that staying on topic. We stayed on the topic of statistics though, but we jumped in between multiple subtopics. We learned about median, mode, central tendency, probability distribution, and a bunch of other stuff as well. There's a list of stuff that I wanted to work on, or well, study or read, and we've made it through almost half of the list. Hopefully, I'll make it through the rest of it later on. I'm probably not going to be reading this stuff off stream. I might just carry on reading this during the next study stream because there's other stuff that I have to do research on. Actually, I can well, I mean, there's no point in showing what exactly the other stuff is. I'm doing research on serial communication between microcontrollers and various peripherals, various modules that you connect to them. Um, I'm doing research on various protocols like UART, SPI, I2C, and I think there's a couple others as well. But these are the three main ones that I want to look into because a bunch of the modules that I do have, they use SPI and I2C like quite a bit. Okay, good. Playing No Man's Sky before going back to drawing the hoodie for my VTuber. Hell yeah. That's awesome. Speaking of VTuber, you guys should go check out Little Witch Oz. Oz is cool people. She's a developer. She's a game developer. She's a She's an artist as well and a gamer. Like, dude, just go check out her streams. And if you like what you see, then drop a follow and hang out and all that good stuff. But I hope you're doing well, Oz. Well, yeah, you did say you're doing good. Um, yeah, yeah, yeah. No problem. No problem. Yesterday we were learning about linear regression, and in linear regression, I was finding a bunch of different topics that I wasn't really familiar with. Stuff like p-value, r squared, kurtosis, skewness. So I was like, okay, I should probably read up on these values because, not values, read up on these topics because um, they're going to come up at some point later on as well in my data science studies. And I also need to carry on practicing, or well, start practicing linear regression because, like, I read up on the theory part of it, but I haven't really fully I haven't done it practically, if that makes sense. So I need to do it practically. I need to find data sets, or I could even create my own data sets and then perform linear regression. First of all, I need to find the line of best fit there. But then I also need to find, I mean, wouldn't I guess finding the line of best fit would also, that would be part of the prediction, wouldn't it? Which brings me to training. So I need to learn how to train the model as well. So there's going to be a bunch of different things that I need to do when it comes to linear regression. And I'm excited. I'm excited to try it out. There's going to be I think I can get a bunch of like data sets from Kaggle, and or I could make my own data sets as well. Yeah. Yeah. Okay, so right now we were kind of hung up on what exactly central tendency is, and I understood the idea behind it. So I can move on now. Moving on to p-value. So in null hypothesis significance testing, the p-value is a probability of obtaining test results at least as extreme as the result actually observed, under the assumption that the null hypothesis is correct. Okay, what if I'm, hold on. Let's skip that and come here. In statistics, every conjecture concerning the unknown probability distribution of a collection of random variables representing the observed data X is some study of statistical hypothesis. If we state one hypothesis only, and the aim of the statistical test is to see whether this hypothesis is tenable, but not to investigate other specific hypotheses, then such a test is called a null hypothesis test. Back up. Hold on. Okay. In statistics, every conjecture concerning the unknown probability distribution of a collection of random variables representing the observed data X is some study is called a statistical hypothesis. The unknown probability distribution of a collection of random variables representing the observed data X in some study. So, okay, the unknown probability distribution is called the statistical hypothesis. If we state one hypothesis only, and the aim of the statistical test is to see whether this hypothesis is tenable, but not to investigate other specific hypotheses, then such a test is called a null hypothesis test. Okay. As our statistical hypothesis will, by definition, state some property of the distribution, the null hypothesis is the the default hypothesis under which that property does not exist. As our statistical hypothesis will by definition state some property of the distribution, the null hypothesis is the default hypothesis under which that property does not exist. How does that make sense if we are connecting that to what was here? So the study of an unknown probability distribution, or no, the unknown probability distribution in a study is called a statistical hypothesis. If we state one hypothesis only, and the aim of the statistical test is to see whether this hypothesis is tenable, but not to investigate other specific hypotheses, then such a test is called a null hypothesis test. See, what I'm not understanding is how we get to this point where the null hypothesis is the default hypothesis under which that property does not exist. Because like when we run some kind of statistical test, we get some property of the distribution, right? It tells us something about the distribution. So what this is saying is that the null hypothesis or the null hypothesis is the default hypothesis under which that property does not exist. So null hypothesis has no observations. It doesn't tell us about any properties of the distribution. The null hypothesis is typically that some parameter, such as a correlation or a difference between means in the populations of interest, is zero. Our hypothesis might specify the probability distribution of X precisely, or it might only specify that it belongs to some class of distributions. Often we reduce the data to a single numerical statistic, example t, whose marginal probability distribution is closely connected to a main question of interest in the study. The p-value is used in the context of null hypothesis testing. Dude, I need a simpler explanation of... Oh shit. I think I accidentally hit the wrong key here, and that's going to shut down the system. Give me a second. Let me try to avoid... not the main system. It's the other system that I was doing the Googling on. Okay, cool. Great. I think we're good. Give me a second while this thing gets back to... Oh, crap. Okay. Give me a second. Give me a second. Is the music still running? Yes, the music is still going. Awesome. By the way, shout out to Scandroid. Go check out Scandroid's music. Synthwave is good stuff. So like, I mean, that's all I can say. Go check it out. Yeah, the music is still going. Thank you. Thank you. Wait, actually, I opened this up and I didn't even look whether the music is still going. I think I just said that, yeah, the music is still going, and I was like, okay. So yeah, it looks like the video is about to finish. So what I'm going to do is I'm going to restart the thing. And so, Oz, I finally set up the split audio thing for my stream. So the VOD doesn't have any music in it. Fortunately, for me, setting it up was relatively simple because the only other sound that I have in my music is that, no, the only other sound that I have in my stream is my own mic audio. Irrelevant thumbnail. Welcome to the stream. Hello, hello. How's it going? We are studying some stats today. And at the moment, I was trying to understand, um what was I trying to understand? I was trying to understand p-value. However, and I know you just arrived in the stream, but I just noticed the time. Um Give me a second. Thanks. Going well here, and you? Sounds like some learning going on in here tonight. Yes, yes. I'm pretty much always learning something. My streams are all about I'm basically always doing study streams or building streams, and this is one of the study streams. Um give me a second. All right. All right. Yeah. But yeah, we do study streams here, and every now and then I'll do some building stuff. I like to experiment with coding stuff a lot. So most of the time, you're just going to be seeing me either learning something or building something. Welcome to the stream. Also, thank you for the follow. Appreciate it. Now, I hate to end the stream like so early. I wish I could go longer, but I do need to end the stream. Um, I'm gonna try and stream again tomorrow. Stick around. I'm gonna be raiding someone. Um, I don't know exactly what they're doing. I think okay. It says they're trying to make a blog for posting recipes, art, and such. Sometimes playing games and stuff like that. Okay, cool. So this is a random streamer that I'm raiding. Let's see. No, it's girls can't rap. Okay, there you go. That's what the thing is. All right, that's funny. Okay, but yeah, that's gonna be it for today's stream. Guys, thanks a lot for hanging out. Oz, thank you very much for stopping by. Thanks for chatting and hanging out. Irrelevant thumbnail, welcome to the stream, and thanks for stopping by. Hopefully I'll see you in the future as well. And anyone else who might have been lurking in the chat, thanks for hanging out. I hope you guys have a nice day, and I will see you all next time. Peace.